Norway produces more than 1.2 million tons of Atlantic salmon every year, generating over 120 billion Norwegian kroner in export value and supplying seafood markets across more than 100 countries. Yet behind this multi-billion-dollar industry lies an increasingly difficult challenge. Sea lice, harmful algal blooms, and extreme weather cost salmon farmers billions of Norwegian kroner every year. While a single toxic algal bloom in 2019 killed more than 8 million farmed salmon, causing losses exceeding 1 billion kroner. As these risks continue to grow, much of the industry has responded by moving farther offshore, building larger cages in deeper and rougher waters. But on Norway's remote Andøya Island, one company has taken a completely different approach. Instead of expanding into the ocean, Andfjord Salmon is investing billions of Norwegian kroner to develop one of the world's most ambitious land-based salmon farming projects. Designed to produce premium Atlantic salmon on an industrial scale, the project aims to combine the natural advantages of the Norwegian Sea with an entirely different engineering concept. So how do you raise an ocean fish without farming in the ocean? And what makes this approach capable of producing tens of thousands of tons of Atlantic salmon every year? Join us as we explore how Andfjord Salmon is redefining the future of modern aquaculture. The success of Andfjord Salmon begins long before the first salmon enters the water. It begins with geography. After evaluating numerous locations along Norway's coastline, the company selected Kvalnes on Andøya Island, approximately 300 kilometers north of the Arctic Circle. Very few places in the world combine all the conditions required for this concept. Deep, cold seawater immediately beside the shoreline, solid granite bedrock capable of supporting massive concrete structures, and a naturally steep coastline that allows seawater to move efficiently through the facility. Rather than constructing a conventional fish farm, Andfjord decided to build what is essentially an artificial fjord, carved directly into the coastline. When fully completed, the Kvalnes development is planned to produce approximately 40,000 tons of Atlantic salmon annually, while the long-term master plan, across 3 locations on Andøya, targets 90,000 tons. The first production phase consists of 5 raceway pools, 1 pilot pool already in operation, and 4 commercial pools under development. Each basin holds around 30,000 cubic meters of seawater, giving the first phase a total water volume of approximately 150,000 cubic meters, equivalent to about 60 Olympic-sized swimming pools. Creating an artificial fjord on this scale meant reshaping the Arctic coastline itself. Engineers first carried out detailed geological surveys to identify granite capable of supporting decades of continuous seawater pressure. Controlled blasting and heavy drilling equipment then excavated enormous cavities directly into the bedrock, before reinforced concrete walls and floors were cast against the exposed granite. The finished structures resemble industrial dry docks, far more than traditional aquaculture tanks. But the pools alone cannot operate without a constant supply of seawater. Beneath the facility lies approximately 4.4 kilometers of underground tunnels, forming the hydraulic backbone of the farm. A main intake tunnel extends roughly 1 kilometer beneath the coastline, drawing seawater directly from the Norwegian Sea. From there, 8 vertical intake shafts distribute fresh seawater into the raceway pools, while 6 outlet shafts collect discharged water before returning it to the sea. Hidden beneath the surface, this tunnel network functions much like the circulatory system of the entire facility. Yet the real innovation is not the tunnels themselves, it is how the entire system uses gravity. One of the largest operating expenses in conventional land-based salmon farming is lifting seawater into production tanks. Millions of liters must be pumped uphill every day, consuming enormous amounts of electricity. At Kvalnes, engineers solved that problem before construction even began, by excavating the raceway pools until their water surface sat almost exactly at the same elevation as the surrounding ocean. Imagine 2 containers connected by a pipe at the same height. Water naturally seeks the same level in both, without being lifted against gravity. Kvalnes applies this simple hydraulic principle on an industrial scale. Instead of using powerful pumps to raise seawater vertically, the Norwegian Sea itself provides most of the hydrostatic pressure needed to move water into the facility. Pumps are used mainly to regulate the speed and direction of the horizontal current, significantly reducing electricity consumption compared with conventional land-based salmon farms. Once inside the system, fresh seawater passes through mechanical screening to remove large particles, before flowing continuously through every raceway basin. Unlike conventional recirculating aquaculture systems, RAS, which recycle 95 to 99% of their water through biofilters, degassing towers, and ultraviolet treatment, Andfjord operates a flow-through design. Every volume of seawater passes through the farm only once, before being discharged under Norway's strict environmental regulations. Even the basin floor is engineered to work with the water rather than against it. A gentle slope guides fish waste and uneaten feed toward designated collection points, where mechanical systems remove the solids before the water leaves the facility. By allowing gravity and continuous flow to perform much of the work, the entire farm functions less like a traditional fish hatchery, and more like an artificial extension of the Norwegian Sea. Once construction is complete and the artificial ocean begins flowing, the focus shifts from engineering to biology. Every production cycle starts with smolt, young Atlantic salmon that have already completed their freshwater stage and are physiologically ready to adapt to seawater. These fish typically weigh 100 to 250 grams when they enter the grow-out facility. From that point, they will spend approximately 12 to 18 months inside the enormous concrete basins, growing into premium market fish weighing 4.5 to 5 kilograms each. At full production capacity of 40,000 tons per year, the farm will produce the equivalent of around 8 million harvest-sized salmon annually, making biological efficiency just as important as engineering. Unlike traditional sea cages where currents depend entirely on tides, wind, and weather, the fish at Kvalnes experience a carefully controlled and continuous water flow every hour of the day. Atlantic salmon are naturally programmed to swim against moving water. Instead of remaining almost stationary, they constantly swim into the current, much like an athlete training on a treadmill. Scientific studies have shown that moderate continuous swimming improves muscle development, heart function, and overall body condition while producing firmer fillets with a more uniform texture. Rather than forcing the fish to exercise, the system simply recreates the natural river and ocean currents that salmon have evolved to navigate for millions of years. The environment also remains remarkably stable throughout the production cycle. Atlantic salmon grow best at temperatures between approximately 8 and 14 degrees Celsius, and the cold seawater supplied to Andfjord remains within or very close to this optimal range throughout the year. Stability is just as important as temperature itself. In conventional sea cages, sudden heat waves or seasonal fluctuations can reduce appetite and slow growth. At Kvalnes, the fish experience almost no abrupt thermal changes, allowing them to maintain consistent feeding behavior month after month. Cold water provides another major biological advantage because it naturally holds more dissolved oxygen than warm water. Oxygen is the invisible fuel that powers every aspect of salmon growth. As long as oxygen levels remain high, fish continue eating efficiently, convert nutrients into muscle more effectively, and recover more quickly from daily physiological stress. Maintaining optimal oxygen conditions therefore directly improves both growth performance and animal welfare. Nutrition is another critical part of the production process. Andfjord Salmon works with Skretting, one of the world's largest aquafeed manufacturers operating in more than 20 countries, to develop scientifically formulated diets for each growth stage. Modern salmon feed is no longer based entirely on marine resources. Today's formulations combine responsibly sourced fish meal and fish oil with plant proteins, vegetable oils, algae-derived omega-3 ingredients, and other sustainable raw materials. Compared with salmon diets used 2 decades ago, the proportion of wild marine ingredients has been significantly reduced while maintaining the nutritional value expected from premium Atlantic salmon. Each pellet is carefully balanced to provide precise amounts of protein, lipids, vitamins, and essential minerals. As the salmon increase in size, both pellet diameter and nutrient composition are adjusted to match their changing metabolism. Feed represents 40 to 60% of the total production cost in commercial salmon farming, making feeding efficiency one of the industry's most important economic indicators. According to Andfjord Salmon, The farm is targeting a feed conversion ratio, FCR, close to 1.0, meaning approximately 1 kilogram of feed produces 1 kilogram of live salmon, a level considered highly efficient in modern aquaculture. Feeding is almost entirely automated. Digital feeding systems distribute pellets across the basins, while underwater cameras continuously monitor fish behavior. If fish activity decreases or uneaten pellets begin sinking toward the bottom, operators can immediately reduce feed delivery. This prevents unnecessary waste, lowers production costs, and reduces the amount of organic material entering the water. Instead of relying solely on scheduled feeding times, the system adjusts according to the real-time behavior of the fish themselves. Fish health is monitored continuously rather than only when problems appear. Water quality sensors operate around the clock, measuring temperature, oxygen concentration, and other critical parameters, while farm staff perform regular veterinary inspections throughout the production cycle. Detecting problems early is essential because diseases can spread rapidly when millions of fish share the same production system. One of the greatest advantages of Andfjord's design is its ability to reduce exposure to sea lice, one of the most damaging parasites affecting the global salmon industry. Sea lice attach themselves to the skin of salmon, feeding on mucus, tissue, and blood. Heavy infestations create open wounds, weaken the immune system, and leave fish vulnerable to secondary infections. Every year, Norway's salmon industry spends billions of Norwegian kroner on sea lice prevention and treatment, while outbreaks also reduce growth rates and increase mortality. By drawing seawater from approximately 160 meters below the surface, where sea lice larvae are rarely found, Andfjord dramatically reduces one of the industry's most expensive biological threats. The deeper intake water also minimizes exposure to harmful algal blooms, which have previously caused the loss of millions of farmed salmon during severe bloom events in Norway. These biological advantages translate directly into measurable production results. According to Andfjord Salmon, survival rates have exceeded 99%, meaning fewer than one fish out of every 100 is lost during production. In comparison, mortality in conventional open-net salmon farming can often reach 10 to 20%, depending on disease outbreaks, environmental conditions, and biological challenges. Every percentage point improvement represents thousands of additional market-ready fish and millions of dollars in potential revenue over the lifetime of a large commercial facility. Once the salmon reach their harvest weight of around 4.5 to 5 kilograms, they are immediately transferred to processing. Speed is essential because freshness directly determines market value. The fish are first humanely stunned, then bled, gutted, and rapidly chilled to preserve texture, color, and flavor. Most of Andfjord salmon's production is expected to be sold as head-on gutted salmon, the global export standard in which the internal organs are removed while the head remains attached. This format allows seafood processors in different countries to produce fresh fillets, smoked salmon, sashimi, frozen portions, and a wide range of value-added products. Atlantic salmon is one of the world's most sought-after seafoods because it combines excellent taste with exceptional nutrition. A typical serving provides high-quality protein, is naturally rich in omega-3 fatty acids, EPA and DHA, and contains important nutrients such as vitamin D, vitamin B12, and selenium. These health benefits have helped drive global demand for salmon higher every year, particularly as consumers shift toward healthier diets. Norway remains the world's largest producer of Atlantic salmon, exporting fish to more than 100 countries. The largest markets include the European Union, the United States, China, Japan, and South Korea, where premium quality Norwegian salmon is widely used by restaurants, supermarkets, and sushi chains. In recent years, Norway has exported approximately 1.2 to 1.3 million tons of salmon annually, generating export revenues of more than 120 billion Norwegian kroner, making salmon one of the country's most valuable export industries. This growing demand creates a significant opportunity for Andfjord salmon. Once Kvalnes reaches its planned capacity of 40,000 tons per year, it will contribute roughly 3% of Norway's annual salmon production. Although that percentage may sound modest, it represents one of the largest individual land-based salmon farms currently under development. Profitability depends on producing premium fish at competitive costs. Andfjord Salmon has announced a long-term production cost target of around 40 Norwegian kroner per kilogram, while market prices for Norwegian salmon frequently fluctuate between 60 and more than 100 Norwegian kroner per kilogram, depending on global supply and demand. At full production, annual revenue could reach several billion Norwegian kroner, making the project one of the largest seafood investments in northern Norway. The economic value extends well beyond the fish itself. Organic waste collected during production can be processed into nutrient-rich fertilizer, recovering valuable nitrogen and phosphorus instead of releasing them into the environment. Meanwhile, the project creates highly skilled jobs for engineers, marine biologists, technicians, and processing workers, while also supporting transportation, equipment suppliers, and seafood exporters across the Vestfjorden region. Despite its impressive technology, Andfjord Salmon is still a multi-billion kroner experiment. The company has shown that Atlantic salmon can be raised successfully on land, but proving the concept is very different from proving it can remain profitable for decades. High construction costs, long payback periods, and fluctuating salmon prices will ultimately determine whether this model succeeds commercially. Even if Andfjord succeeds, its exact design is unlikely to spread everywhere. Only a handful of regions, including Norway, Iceland, Chile, the Faroe Islands, and parts of Canada, combine the cold seawater, deep coastlines, and natural geography required for this concept. For most other countries, different technologies will still be needed. Yet the project's greatest achievement may already be clear. It has challenged one of aquaculture's oldest assumptions, that Atlantic salmon must be farmed in the open sea. Whether this becomes the industry's future or remains one of its boldest engineering experiments, only time will tell. What do you think? Could land-based salmon farms eventually replace traditional sea cages? Let us know in the comments below. If you enjoyed this video, don't forget to like, subscribe, and join us for more stories about the extraordinary engineering feeding our world. Thank you for watching.